In today's lesson, we'll be learning about the primary trigonometric ratios. We use a mnemonic called SOHCAHTOA to remember them. SOHCAHTOA is a mnemonic which helps us remember the three primary trigonometric ratios. SO contains the letters S, O, and H, which corresponds to sine theta, which is equal to opposite over hypotenuse. Ka contains the letters C, A, and H. That corresponds to cos theta, which is equal to adjacent over hypotenuse. TOA contains the letters T, O, and A, which corresponds to tan theta, which is equal to opposite over adjacent. It is important to remember that SOHCAHTOA only works for right triangles. How do I indicate that these triangles are right triangles? We use a little square. That indicates that that angle is 90 degrees. By now, you should know that the hypotenuse is the side opposite to the 90-degree angle, which makes this the hypotenuse, as well as this the hypotenuse. The hypotenuse is the longest side in a right triangle. Where exactly are the opposite and adjacent sides? Well, that's a little bit of a tricky question because the opposite and adjacent sides are relative to the angle which you're currently looking at. So let's say, for example, I'm looking at this angle, which I'm going to call theta. Theta is just a Greek letter. That would mean this is the opposite side relative to that angle, and this is the adjacent side relative to that angle. Now, let's say I'm looking at this angle. That means this would be the opposite side relative to that angle, and this would be the adjacent side relative to that angle. So it is really important to remember that the opposite and adjacent sides are relative to the angle which you are looking at. However, the hypotenuse is always going to be opposite to the 90-degree angle. It is going to be the longest side in the right triangle. In our first example, we want to determine which trigonometric ratio should be used. The first thing you should do is look at the angle which is given. That is an angle of 43 degrees. Everything is going to be relative to that angle. So, the side length of x would be the opposite side, while the side length of 3 meters over here would be the adjacent side. Now, you have to think about your mnemonic, SOHCAHTOA. Which of these ratios contains the letters O and A? That would be TOA, which means the trig ratio you should be using is tan theta, which is equal to opposite over adjacent. In our other example, we've been given the angle of 54 degrees. Remember, everything is relative to that angle. So the side length of y would be considered the opposite side. Meanwhile, the side length of 28 meters would be considered the hypotenuse, since that is opposite to the 90-degree angle. So, you need to think about your mnemonic, SOHCAHTOA. Which of these ratios contains the letters O and H? Well, the trig ratio that contains O and H is SO, which stands for sine theta, which is equal to opposite over hypotenuse. In our second example, we want to determine which trigonometric ratio should be used. Again, the first thing you should look at is the angle which is given, that is 48 degrees. Remember, everything is going to be relative to that angle, which means the side length of W is going to be called the adjacent, whereas the side length of 17 centimeters is going to be called the hypotenuse. The hypotenuse is always opposite to the 90-degree angle. So at this point, you need to remember your mnemonic of SOHCAHTOA and think about which ratio contains the letters A and H, and that would be Ka. So that is cos theta, which is equal to adjacent over hypotenuse. In our other example, we want to determine which trigonometric ratio should be used. Again, you want to focus on the angle which has been given, which is 28 degrees, and everything else is going to be relative to that angle, which means the side length of 12 meters is the adjacent side, while the side length of x is going to be the opposite side. Now, you're going to have to remember your mnemonic of SOHCAHTOA and think about which ratio uses the letters O and A. And that would be TOA. So the trig ratio that you should be using is tan theta is equal to opposite over adjacent. In our third example, we want to find the length of x to the nearest tenth. So first thing you want to do is focus on the angle which has been given, which is 43 degrees. That would make the side length of x the opposite side. And that would make 3 meters the adjacent side. You need to think about your mnemonic, SOHCAHTOA. Which ratio contains the letters O and A? That would be TOA. So we should be using the trig ratio of tan theta is equal to opposite over adjacent. At this point, you want to substitute in your known values. I know what the angle is, so instead of writing theta, I'm going to write 43 degrees. And instead of writing opposite, I'm going to write x, and instead of writing adjacent, I'm going to write 3. What exactly is tan of 43 degrees? Well, you're going to need to use a scientific calculator to figure that out. You're going to punch that into your calculator and you're going to get a very long number. I only want you to take a few decimal places, so I'm going to round it to 9325. Everything else stays the same. To figure out what x is equal to, we're going to need to cross multiply. So I'm going to change that into a fraction, and I'm going to cross multiply, which is going to give me 0.9325 multiplied by 3, which is equal to 1 multiplied by x. When you multiply 0.9325 by 3, you're going to get 2.7975. And anything multiplied by 1 stays exactly the same. But remember, we need to find the length of x to the nearest tenth. So that means we're going to have to round this number, which means this rounds to 2.8. So 2.8 is x. So I need to write a concluding statement. Therefore, x is 2.8 meters. In our fourth example, we want to find the length of AC to the nearest tenth. So let's label AC. Let's just call it x. So first thing you want to do is focus on the angle which has been given, which is 38 degrees. Remember, everything is relative to that angle, which means x would be the hypotenuse, since it is opposite to the 90-degree angle, and 12 centimeters would be the opposite side. You need to recall your mnemonic of SOHCAHTOA. We need to look for a ratio which contains the letters O and H. And the ratio that contains O and H is SO, which is sine theta, which is equal to opposite over hypotenuse. At this point, you want to substitute in your known values. Instead of writing theta, I'm going to write 38 degrees. And instead of writing opposite, I'm going to write 12. And instead of writing hypotenuse, I'm going to write x. To figure out the sine of 38 degrees, you're going to need to use a scientific calculator. You're going to get a long number, but I only want you to take a few decimal places, and that's going to be about 0.6157, and everything else stays exactly the same. figure out what x is equal to, we're going to need to cross multiply. So let's go ahead and do that. I'm going to get 0.6157 multiplied by x, and then 1 multiplied by 12. Let's clean up some of these numbers. So 0.6157 multiplied by x, that stays exactly the same. Anything multiplied by 1 stays itself. So 1 times 12 is 12. Now, we want to isolate x, but x is stuck with this 0.6157. So I'm going to need to do the opposite operation. I'm going to need to divide by 0.6157, and I'm going to do that to both sides of the equation. That cancels out. You're going to take 12 and divide it by 0.6157. You can throw that into your calculator, and you're going to get 19.4900. Don't forget, you need to round this to the nearest tenth. So that would round to 19.5. And we do need a concluding statement. So I'm going to say, therefore, x is 19.5 centimeters. In our fifth example, we want to find the measure of angle x to the nearest degree. The first thing you want to do is focus on the angle, which is angle x. Everything is relative to that angle, which means 15 centimeters is going to be the hypotenuse since it is opposite to the 90-degree angle, and 11 centimeters is going to be the adjacent side. At this point, you need to remember your mnemonic, SOHCAHTOA. We need to find a ratio which contains both a and h, and that would be ka. So cos theta is equal to adjacent over hypotenuse. In our next step, we want to substitute in our known values. So instead of using theta, we are specifically looking at angle x. So I'm going to replace it with x. Instead of writing adjacent, I'm going to write 11. And instead of writing hypotenuse, I'm going to write 15. I can't really do anything with cos x, so I'm going to leave it be. However, 11 divided by 15, you can throw that into your calculator, and you're going to get approximately 0.7333. Remember, we want to figure out what the angle x is equal to. However, x is stuck with this cos. How do I get rid of this cos? You can't divide both sides by cos. You're going to need to use a special button on your calculator. It's called cos inverse. So it's going to be cos with a -1 in the upper right corner. If you have a scientific calculator, you're going to need to either press the second function button or the shift button to access this function. And the 0.7333 stays the same. If you throw that into your scientific calculator, you should get approximately 42.8 degrees. But remember, we want to find the angle to the nearest degree. So we need to round this, and this rounds to 43 degrees. I'm going to put a concluding statement. Therefore, angle x is 43 degrees. In our last example, we want to find the length of y to the nearest tenth. The first thing you want to do is focus in on the angle which has been given, which is 54 degrees. Remember, everything is going to be relative to that angle, which means the side length of 28 meters is going to be the hypotenuse since it is opposite to the 90-degree angle. And the side length of y is going to be the opposite side. Now, you need to remember your mnemonic of SOHCAHTOA, and you need to think of a ratio which contains the letters O and H. That ratio would be SO. SO stands for sine theta, which is equal to opposite over hypotenuse. In our next step, we want to substitute in our known values. So instead of writing theta, I'm going to write 54 degrees. Instead of writing opposite, I'm going to write y. And instead of writing hypotenuse, I'm going to write 28. Now at this point, you can put sine of 54 degrees into your scientific calculator and figure that out. It's going to be equal to approximately 0.8090. Everything else stays exactly the same. Remember, you want to figure out what y is equal to. To do that, we're going to need to cross multiply. So what I have is 0.8090 multiplied by 28, and then 1 multiplied by y. So if you go ahead and do that in your calculator, so 0.8090 multiplied by 28, you're going to get approximately 22.652, and anything multiplied by 1 stays exactly the same. So 1 times y is just equal to y. But don't forget, we need to express our answer to the nearest tenth, which means we are going to round this to 22.7. And let us write a concluding statement. Therefore, y is 22.7 meters.